Hey everyone, today we're going to be learning about covalent bonds. So in the last video you guys learned about ionic bonds where a positive ion gives away its electron, a negative ion takes it, and the attraction between the two keeps those two elements together. So table salt, NaCl, is always going to form an ionic bond, and there's another type of bond called covalent, which instead of one element giving away its electron and becoming positively charged, two elements are going to share their electrons. In the case of water, right here, we have the electrons from hydrogen being shared with the electrons from oxygen. So a good, easy example of a covalent bond would be like chlorine gas, or Cl2. If we look at the same chart that we looked at yesterday, we know that in an ionic bond, chlorine is always going to take one electron. In a covalent bond, chlorine is always going to form one bond. Because chlorine, fluorine, bromine, iodine, everything in the halogen family has 7 valence electrons, it wants to get 8, so it's going to form one bond to get to that 8. And for ease sake, we're going to put hydrogen in this category as well. Oxygen, sulfur, everything in this family that normally forms a -2 charge in an ionic bond is going to form 2 bonds when we have a covalent bond. Nitrogen, phosphorus, this whole family that would normally form a -3 charge when we have a covalent bond is going to form 3 bonds. And anytime we deal with carbon in any of these equations, carbon will form 4. For this unit, everything that we're going to be dealing with is going to be on this side of the periodic table. We're not going to be dealing with anything that has a positive charge. But when a chlorine atom is bonding with another chlorine atom, each one has 7 valence electrons. They want 8, so they're going to help each other out here, and they're going to share an electron, or they're going to share a pair of electrons. So this pair right here, this would be called like the bonding pair. So we could just draw it like this, that you have 1, 2, 3, 4, 5, 6, 7, and then it's going to share this, so these 2 electrons are going to count as electrons for both of them. So both chlorines now have 8. So next example, we have CH4, or methane, and if we look back here, we know carbon forms 4 bonds, and hydrogen forms 1 bond, and we also have 1 carbon and 4 hydrogens. We're going to go ahead and put the carbon in the middle and the 4 hydrogens around it. All right, so we know carbon is going to form 4 bonds, and each hydrogen will form 1, and we have 4 hydrogens, so this works out perfectly. So these electrons will be shared. So now this this hydrogen has formed its 1 bond. These will be shared, these will be shared, these will be shared. So now, if we just go around the circle, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons surrounding the carbon. So my carbon has all 8, and it's formed all of its 4 bonds. Right, so last example, we have PCl3. So we find phosphorus right here, and we know phosphorus will form 3 bonds, and we have 3 chlorines. Chlorine is going to form 1 bond each. So we can go ahead and put phosphorus in the middle, and then we can go ahead and put the 3 chlorines surrounding it. Right, so we have 5 valence electrons around phosphorus, and it's going to form 3 bonds. And we have 7 around chlorine. Chlorine is going to form 1 bond each. Chlorine can only form 1 bond, so it'll share one of its electrons with phosphorus. Same thing with this chlorine and this chlorine. We do that 3 times. So now phosphorus has all 8 of its electrons, and each chlorine also has all 8 of its electrons. So this would be the structure of PCl3. So I hope that was helpful, and if you guys have questions, feel free to reach out and I can help you with any of the questions you still have on this.